Okay, so it's been 2 to 3 days. I will not here. Um, so let's solve this puzzle. The above network shows 7 cities A, B, C, D, A, B, C, D, E connected via two-way roads and one-way roads. For the one-way roads, the direction of travel is as indicated by the arrows in the diagram. Roads which do not contain any arrows are two-way roads. Okay, basically two-way roads. Last question. The number of distinct paths from city A to city G. A to G. Distinct paths from city A to city G without going through any city more than once. Okay. So city A to city G. This is our path. How many ways we can go? One, two. Here, two options are there, right? Now let me write it down like this: A and G. A to 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. This is not possible. So A, B, C, F, G. That's one option. Another is A, D, E, and G. Another is A, D, E, E, C, F, and G. Okay. Anything else from this route? Can't go this. D, A, D, E, F, and G. This is done. Now here A, B, C, D. A, B, C. This way will come. That's also possible, right? Yeah. Write that first. A, B, C, C, A. Is it possible again coming to the number of distance from A to C without going through any city more than once? Okay, yeah, that's not possible. Coming twice, yeah. So A, B, C, D, E, and G. A, B, C, E, C, F, and G. A, B, C, E, and G. A, B, C, E, F, G. Okay. A, B, C, D, E, F, G. Yeah. A, B, C, A, B, C, D, E, D, E, D, C, F, E. Another A, B, C, D, E, F, G. Oh my god. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. There is no option for 9, so definitely it's 10. If two roads connecting C and F is under repair, if two roads connecting C and F, okay, this is under repair, and traffic cannot flow through it, then the number of distinct ways in which city G can be reached from city B, from B, without going through any city more than once. Can I redraw this diagram to make it bit? How can I? At A here. Okay, it's B. From B we can go to A. From B we can go to C. From C we can go to A. C we can go to D. C we can go to E. C we can go to F. Okay, A to D is also possible. C to D, A to D, that's possible. D to E, C to E, that is also possible. C to F, F to C, E to F is this way. D to E, what is the way? D to E is what? C to D, C to D, C to A, this way. And E to G is also possible. F to G is also possible. So these are the two options. And here C and F. C, F, this is not working. So this is not working. Now, okay, how many? Let's take from this one. B, A, D, E, G. 1. B, A, C, D, E, G. 1. B, A, C, E, G. 2. B. Here we can go this way also. 4. Right. Now this way also 2 options. Right. Now here also the same way, right? 1, 1, 2, 3, 4, 5, 6. 6 ways. Here's 6 ways. And here 1, 2, 3, 4, 4 ways only. That means 10 total. Any city more C and F is again, it's like this. I took it 8. Okay, since it is 10, definitely was 2 is there is B 1 1 1 2 2 options are there for here too. 3, 4, 5, 6. 6 options only. Oh yeah. 7, 8. That's how it is set, right? Got it. Now, if two-way traffic is allowed on all the roads, then the number of distinct ways of reaching city G from D without going through any D to G. D to G. So D, E, and G is one way. D, C, D, C, E, and G. Then D, C, E, G. D, C, F, G. D, C, F, G. D, E, A, B, C, F, and G. What's the easiest way to do this kind of problem? It's easy, but it's time consuming. Let's go to the another question. The following sketch shows the pipelines carrying materials from one location to another. Each location has a demand for material. The demand at Vaishali is 400. This is Vaishali, it's 400. At Jyotismati, it is 400. Okay, here it is 400. What is this? Panjal, it is 700. Some materials. Then let's add Vidasha, it's 200. What about Avanti? Each arrow indicates the direction of material flow through the pipeline. The flow from Vaishali to Jyotishmati is 300. 300 liter per hour, maybe. The quantity of material flow is such that the demands at all these locations are exactly met. The quantity of material flow such that the demands at all these locations exactly met. The capacity of each pipeline, capacity of each pipeline is 1000. What do you mean by that? Each pipeline can carry a maximum of 3000 liter flow. Is it that? The quantity moved from Avanti to Vidisha is Avanti to Vidisha. How much? It's 400, 400, 700. Okay. Here it is 700. That means here. So here it needs 200. So here 200 plus whatever center for this or this place, right? And here, okay, maximum it can carry 1000, right? So if it will carry 1000, then 400 will give here 600. Okay, it's already 300 only going through this area. That means here it has to pass a minimum 100, a minimum. Okay, plus let's see, So 400, then it's not minimum. 100 plus whatever it's 700 also need to go through this, no? Right. So 800 is passing through this place. That means here the value is 1000. 200 give here, 801 to this. Okay. Now here 300 plus 400, 700 1 through this way. How much need for Avanti? That we don't. The quantity moved from Avanti to Vidisha. Avanti to Vidisha is 1000. The free capacity available at the Avanti Vaishali pipeline. Avanti Vaishali. Free capacity is 300. Okay. The following figure now. Let's go to another. The following figure represents flow of natural gas through pipeline between major cities ABC and D in suitable unit. In suitable unit, okay, in whatever units. Assume that supply equals demand. Supply equals demands. Okay. Refer to it and answer the following questions. That's what's the question. What is the number of units demanded in B? Flow of natural gas through pipelines across major cities. From 1000, let us going through this. 300 is coming to here, and 650 is going to there. That means how much? 350. $650 D needs, right? 650 single needs. So that is okay. Now here for B, 1000 is going here, and 550. 550 and 250, 800. That means 400 get at B. Now units demanded at B. If the number of units demanded in C is 225, if it is 225, what is the value of M? What is the value of M? If it is 225, how much it's going out? 300 plus 800, 1100. 1100 is going out, and how much it is coming? It has to be 1100 plus 225. Okay. Oh, what is this? 250 is coming, that we know. That means 1000. That means 250 we have to remove from this, which is 750, 850. 850 is coming. 850 plus 225 is coming, and 225 stays here. No, it has to go this much, right? That means no. Yeah, about that. 250 is coming. We need 225 at C. Right. What is that? 475. Remaining how much? 475. We have and the M. Okay. We add M plus 475 and minus 225. Oh, why am I making this much complex? It's M plus 250. It's incoming and out is this. Here we have to remove 225, right? That is M plus 25 equal to 1100, or M equal to 1075. Okay. If the total demand is in E is 80% of demand A, that is 0.8 of A. What is the demand of A? How much it is coming here? 6. What is this? 650. 650, 700, 1200, 2000, right? Which is 80% of A. Or A is 2000 by 18. That means how much? 5000. 5000. Okay. Assuming the information of question number 2 and 3 to be true, 2 and 3 to be true. Okay. What is the total demand in 5 cities? So 5 cities, 5000, 2000. Huh? 80% of 5000 is 2000. How come? Uh, it's 250, 500, 500, it's 2500. 7500. Okay, this 80% of this is 250, 500. So yeah, A base 400, says 225, D 650 is 2000, 4500, 4900, 5550, 5775. Yeah. The above, let's check this one. The above sketch shows the pipelines carrying oil from one unit to another and from the storage unit A. What? The above sketch shows the pipeline carrying oil from one unit to another and from the storage unit. Where the storage is? Okay. Each unit has a pre-desired demand for oil. The demand at B The most sketch shows the pipeline getting oil from to them. And from the storage and each unit has a pre-decided demand for oil. The demand at B is 1200 liters. Fine. At E is 400. That's also fine. And at C and D each is 700. Also, each arrow indicates the direction of flow through the pipeline between any two units. Okay, the capacity of each of the pipelines is 2500 liters. The pipeline between units A and B is working at full capacity. That is A is 2000 flow and B is 2000. The pipeline between the units, okay, and full capacity. The total amount supplied by the storage unit A is equal to the sum of the demand at all other units. Okay, that means 1200, 1600, 2600, 3000, 3000. The flow of oil in the pipeline joins A and D will be A and D. 1200 were left. So 500. Okay, this much. 700. 700 left here. That means 600 is remaining. Yeah, okay. 600 will come to here. 100 go to no, not 100 because 600 is remaining. 400 will went through this way, then 200 this way, 500 this way. Okay. The flow of oil in the pipeline joining A and D. A and D is 500. How many of the given 5 pipeline segments are carrying? Given 5 segments are carrying less than 20% of the capacities. This is 400. Capacity is 2500. Less than 20%. That means less than 20% is 500. Less than 500. 1, 2. Just 2 pipelines, right? If the difference between the capacity of a pipeline and the amount of oil flowing in it is called slack in that, oh, whatever. If the difference between the capacity of a pipeline and the amount of oil flowing in it is okay. It's called as the slack in that pipeline. What is the slack in the pipeline connecting units C and D? C and D. Flow is 200 and the capacity is 1400 means 1200. Pipeline. Okay, capacity 2500 minus 200 is 2300. Done. Let's see this. The network shows the water pipelines connecting the 6 cities. Water can flow only is in the direction indicated by the arrow. Fine. The maximum carrying capacity of pipelines leaving A, that is A to B and A to D is 1500. Okay. X and Y. X plus Y max maximum is 1500, right? Meter cube per day, while that of others is 1000 meter cube per day. Carrying capacity of pipelines leaving. Huh? Maximum capacity, carrying capacity. It's like that. Just these two people's maximum capacities are 1500 maximum, 1500 liter maximum. All others are 1000 liters maximum. The daily requirement at C and D is in the ratio C and D is in the ratio 2:3. So 2x and 3x. Water flow in pipeline BE. Flow in pipeline B is 600 meter cube. Okay. Slack in pipelines CE, CF is the same. CE, CE, CF. Slack, slack is something, yeah. Capacity minus the flowing amount, right? That basically means the capacity is the same. Oh, sorry, the flowing amount is same, right? Daily requirement here, this is K. Let's put it as K. Daily requirement at D and E is in the ratio 2:3. D and E. This is also 2:3y. Or if you multiply 6y 9y, which is equal to 6x. Mm, 4x. Okay. 6. Yeah, so same only. Is x equal to y, which means this is 9x. Slack in AB is 200. AB is 200. That means it's going through is 1300 liters. Less than that slack in AD. So, that is EAB and AD. AD is 1500, then it is 1300, 1200, then 1000. That will be a hell of things. Difference in the daily requirement at C and E. C and E. There is 4x minus 9x, which is 5x is equal to 500, x equal to 100. What? So that means this is 600, this is 900, and this is 400. Slack in AD and the flow in dB is in the issue. AD, and the flow in D. Flow in dB is in the ratio 1:2. So let's see the flow here is yum. So 1500 minus yum divided by, here it is BD, right? Or dB. dB 1/2, or then just let's keep it this first reference. Find the daily requirement at F. If it is known that its requirement is exactly met by the water flowing through the pipeline shown. Okay. Here it is 600. It's 900. Let's clear. 600 came to this. Then 300 has to become to this. And this is also 300. So F has 300 flowing through the pipeline. The requirement that F. Find the daily requirement meter cube at B. If it is known that requirement at all the cities are exactly met by water flowing through the pipeline shown. In that way, 600 left here, 400. 400, 300, 300, right? 700,000 has to flow through this maximum capacity. That means here, here, how much? And the recommended to beef this 1600 if it goes through here. Yeah, so minimum 600 has to go through this way, right? It is a minimum 600 and there will be nothing to this way. Okay. Yeah, this relation. What is this relation? 3000 minus 2m is equal to dB. dB by 2 plus m is equal to 1500. dB by 2 plus m. This 2 has to, like, yeah. Add these two. Okay, add this plus half of this. So 1500. Okay. Find the element is now the recommended also exactly met. So here it's 300. This is fine. This is fine. This is fine. This is the ratio, and this m. Here it need to be plus 200. Whatever it's trying to the through here minimum 600 has to pass, right? Like, let's suppose if it's passing 600 here and 1005, no, 600 let it pass on 400 only, right? So let's take the maximum value, 1500 passing through this, 1300 this. Okay, 600 rand, remaining 900. Is it in the ratio? 1500 minus 1500, 0. That's not possible. 1400, 1200. That is 100, 600, 800. Oh, wow. By 8. No. PM maximum 500. So this is fine. DB photo. Oh, also 1500 yeah, to D. No. Mhm. I don't think so. It's but there's chance. How to solve this? How to solve this? Mm-hmm. Any idea? Hmm. I am bored. Let's go to another question. The following is a network of 6 dams. Where S is the source dam? Where is a source dam? Which provides just the necessary separation. That's like anyone. Other dams and has no minimum requirement for itself. In the diagram, the direction of flow in the canal is connecting one dam to the another. Other is given. Neither the requirements at any dam nor the flow in any of the line is 0. That is always a multiple of 100. Further, the requirement at A is 500 and 500. Okay. And that at E is same as that of B. E and B. Let's call it X now. The requirement at C is twice that of D. Yum. 2 The total of the flows in the canal connecting A and C, and that connecting B and D, B and D is 900. This guy plus this guy. Okay. The flow in the canal connecting S and B. S and B, what is S and B? Okay. S and B. 100 less than the flow in the canal connecting S and A. That is, if it is A plus 100. Okay. The maximum possible flow in a canal is 900. Okay. And for in a canal, the difference between the maximum possible flow and the actual flow is called a slack. That canal. Fine. The slack in the pipeline connecting C and E. C and E is 700 and the maximum is 900. That means here it's 200. Pretty simple. Is it? Let's see. I'm getting some Mali table. This is B. This is C. This is D. B plus C is 900. Since it's all multiple of 100, this can be 100 plus 800, 200 plus 700. What? Goes and goes and goes. Okay, what's the question? What is the difference between the requirement at C and E? For C and E. Mm. This is direction. This is direction. This is direction. That means if these two people are going through here and to here, okay, we can make some connections here also. What is connection? Like here, okay, B, C, D, E, F. So what I'm guessing. A plus E. A plus E plus X. A plus E plus X. Okay, this guy. Aha. What, what I'm looking for? Hmm. What is it? That is the difference between the comments at C and E. C, 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 and E. What? What is the difference between the comments at C and E? Oh, it's already good. It's 200. What is the slack in the canal connecting the dams A and C? And C. That we do know. F plus B minus C is equal to 200. It's correct. B plus F C is M minus M is equal to 200. Now here, what is the equation? C plus, now C minus 2M equal to F plus D. And if you add these two, B plus C plus F minus 3M is equal to 200 plus F plus D. B plus C is 900. F plus of that cancelled. 900 minus 200, that is 700. Minus D is equal to 3M. Any other stuff? Wait. This has to be a multiple of 3 and 100. What are they? 300, 600 and 900. So it need to be like we have to minus, that means 300 or 600. If it is 300, EMS, if it is 300, let's suppose it is 300, then this will be 100. These are so 100. D will be what? This 100, right? If this 100, 3M is 600, M is 200, and this will be 400. Mhm. This is 200, 400, 400, 500, 600, 700, 800, 900, and that will be 0. Yeah, this sum like 200, 400. 200, 400, 500, 900. Yeah, that means here it will be 300. Okay. It needs to be a minimum 100 through F, right? That is 400, 500, 600. A minimum of 600 to go through here. 6, then it has to be 300. If it is 700, 400, and 200 will go through this. It has to be 200. That's also possible. Axis, this is 300 and this 300. Ah, I'm so sleepy. Ah, fine. Interesting. So let's try it solve. 1, 2, 3, 4, 5, 6. Perfect.